Filtering data. A common task in data science work is filtering data so we can work with just the data we're interested in. With the where clause, we can filter numerical and character data. Where clause can contain several filters combined with the Boolean logic. Filtering numeric values is straightforward. We'll use the company by sector table for this example. Let's assume we want to list every company with a stock price greater than 1,000. Since we only want to include a certain subset of the companies, we use a where clause. We will set the numeric filter to show the companies where the stock price is greater than 1,000. As a result of the query execution, we receive a subset of data with the list of companies that satisfy our filter settings. Filtering based on character strings works in similar ways. Now let's generate a list of companies which belong to the information technology sector. We create a new filter where the sector column values should be equal to information technology. Now the query execution results window has all companies belonging to the information technology sector. Now we can combine the two filters. Composite filters are quite common. Sometimes, where clauses can be the longest part of a select statement because there are so many conditions that need to be satisfied. To filter for rows that satisfy both conditions, we use the AND keyword. For example, we want to find companies from the information technology sector with a stock price greater than 1,000. For that, we combine the two filters we previously created. The query results show two rows which represent one company, Alphabet, that owns Google. The two tickers are the result of the stock split in 2014. Now, if we want at least one of the conditions to be met, but maybe not both, then we can use the OR keyword. In our filter, we change the AND to OR, execute the statement, and observe that there are two companies in our data set which are not in the information technology sector. Let's stop here and talk about code formatting. You probably noticed that we started using left indent in the query strings. There is no single rule for styling the code. However, we think it is a good practice using indents in complex queries. SQL is a programming language. As with any other language, you may like to take an extra effort to improve readability of your queries. This will pay off later when you will start editing and debugging your code. Now let's move on to the character filters. In SQL, the like operator is used to determine whether a character string matches a specified pattern. A pattern can include regular characters and wildcard characters. There are many options for working with the like operator. Before we show the example, we want to explain what the term wildcard character means. Wildcard character is a special symbol which can stand for a certain range of characters. Here is the table of wildcard characters used with the like operator. The most used wildcard character is the % symbol. It represents any string from an empty space to a string with any number of characters. For example, if we wanted to find all companies with the abbreviation Inc. in the name, then we should construct the following filter. With that, we include companies that have a comma after the Inc. string. Note that we added a space in front of the Inc. to distinguish the abbreviation from Incorporated from an accidental case where the company can have Inc. characters inside the title. If we add not to the like operator, then we can filter companies with the names that do not have Inc. in their names. We need to mention that you have to be careful when using % at the beginning of a string. When this happens, the database cannot use indexes that may be on the column. This will cause the database to scan every row in the table looking for matches. It will still work, but might take longer time than you expect. Another example of using like operator with the percent wildcard is to list companies whose names start with A. We can create composite filter and list companies whose names start with A or B. For that, we can use two filters with a percent symbol which start with A and B. We can also use the square bracket wildcard to construct the same filter. If we want to list companies with the names that do not start with A or B, we can use not like operator or square brackets with the caret. If for some reason you are looking for companies with 6 letters in the title, you can use the like operator with 6 underscore wildcards. Alternatively, you can use the len function that returns length of the string. Query with the filter where length of the string is set to 6. This will return the same results as the query with the underscores, but is more readable. Subqueries. We usually select data directly from tables and views, but sometimes we might need to get data from the results of another select statement. We can do this using SQL subqueries. Subqueries can be used in 3 different parts of a select statement: in the select values list, in the from clause, and in the where clause. Let's work through an example of each of these 3. At first, we will introduce concept of prefix. Since we have multiple select statements within a single query, we'll want to make sure the database can tell which table each value comes from. To do this, we will use a table alias and include that alias as a prefix for each value we will return. In our example, the table company by sector has alias T1. So all columns retrieved from the table T1 has to have the prefix T1. Now we will create a subquery that will calculate average stock price by sector. For that, we will use the same table, company by sector, but with a different alias. We will call it T2. We add a restriction that we are interested in the average by sector, and the sector names in the table T1 and T2 should match each other. In some sense, we are joining our table T1 with the list of calculated average values. We will look deeper at the join conditions in when we study table joins. Let's look at the query one more time. Here we have the subquery that calculates the average stock price from the company by sector table, but only using rows where the sector name is equal to the sector of the company the algorithm is currently looking at. Note that we place the subquery where we would usually have a column name. We call the new column sector average. In the results table, we see that we have added an extra column, sector average. This column lists the average stock price for the corresponding sector. Let's look at another example of how to use subqueries in the from clause. At first, we construct the plain query for retrieving sector names and stock price values from the company by sector table. Now we want to know average stock price by sector, but we are only interested in companies with the stock price greater than 100. We can find this information by constructing a subquery in the from clause with the where filter. Basically, we will select from the results of another select statement. As before, we will add an alias T1 to name the results of the subquery. Here we add one more clause, group by, for explaining the SQL engine that we want to calculate average stock price by sector. The results table shows the list of sector names with the average stock price. Note that only the companies with the stock price greater than 100 were included in the average. You may notice that we did not use prefix in the column names. We did so to demonstrate that the SQL engine is smart enough to understand our needs. Here you may see that the results of the query with prefixes are the same as without. However, we recommend using prefixes for improved readability and debugging purposes. Prefixes are essential when you work with more complex queries. Another place where you can incorporate subqueries is the where clause of the select statement. These subqueries can be used when we want to make comparisons within a single table. For example, if we want to find the sector of a company with the highest stock price, we can use a subquery in the where clause. This subquery will find the maximum stock price in all sectors with the max function. Then we will use this maximum value in the filter to find the company sector name. Note that we used different aliases and prefixes T1 and T2 for each select statement. This query will work without aliases and prefixes. However, we recommend using it. Also, you might note that we used single spaces as the indents. Again, use of single or double space indents or not using indents at all is a matter of style. We intentionally vary indents along the examples to demonstrate various styles. You pick the one that works best for you. Combining Tables, Part 1. You might hear the term joining tables, which is a common operation in SQL. However, the range of commands that SQL Server has for combining tables is wider. We will cover joins, union, intersect, and except. Table joins is one of the key features of the structured query language. When working with data, we sometimes need to retrieve data from two or more tables. For that, SQL has several variations of join command: inner join, left, right, and full outer join, and cross join. Although the join commands work with tables, sometimes for illustration purposes, the tables are shown as circles. The inner join command, or the simple join, returns a table that has records which conform between table A and table B. Here we should say that in order to make the join possible, both tables should have similar columns. For example, table A has stock tickers and the stock prices, while the table B has stock tickers and company names. The joined table will have the list of stock prices and company names for cases where the rows in both tables have the same tickers. We will explain this statement when we show examples. The left outer join results in a table that has all rows of the left table, table A, and rows from table B, the right table, that match the join condition. The right outer join is the inverse of the left outer join. Actually, the words inner and outer are optional when it comes to the writing the commands. It's okay to skip it. You can write and say only join instead of the inner join, and left join or right join instead of left outer join or right outer join. The full outer join command produces a joined table that has all rows of table A and table B. The columns with unmatched rows in the resulting table are empty, or, better to say, are filled with the value of none. The cross-join command can be considered exotic. However, there are cases when it helps to reduce the amount of data manipulation actions. With the cross-join command, we can generate a data set where for each row in the table A, we will have all rows of table B. The following examples will clarify each of these join commands. In this example, we will demonstrate how to use the join commands. At first, we will create two tables in our S&P 500 database. For that, we will use the create table command. The new table, named Table A Company Stock Prices, will have two columns, the column with tickers and the column with the stock prices. We will populate the table using insert command and insert values for tickers and stock prices in 4 rows. The insert command is used to add new rows to the table one by one. To add 4 rows, we need 4 insert statements. Now we will create another table named Table B Company Names with 2 columns, ticker and company name. We will add rows to this table in the same manner as before using 4 insert statements. The first 3 rows will contain the same tickers as in Table A. The last column will contain ticker that does not exist in the Table A. We made that to illustrate the difference in the join commands moving forward. Now let's select data from Table A and Table B and execute the 2 select statements in the same query batch bounded with the Go command. Note that 2 select statements in one query batch resulted in 2 tables in the output window. Also note that the 4th rows in both tables have different company tickers. Now we will give an example of the inner join command. This select statement will combine ticker, company name, and stock price columns from Table A and Table B. The join operation is performed on the column ticker. To differentiate the tables, we add prefixes TA and TB to the column names. The result of the inner join operation is a new table with 3 rows with ticker values, company names, and stock prices of those companies. The 4th rows in each table were skipped since the ticker values did not match each other. The keyword inner in the inner join command is optional. The same query will work in the same way without the inner keyword. Now let's examine the left outer join command. The select statement is similar to the inner join command that we created before, except now the join command is called left outer join. The resulting table has 4 rows. All data from the left table, here Table A, is included. However, the last row has the null value in the company name column. This happened because the right table, Table B, did not have information on the company name for the record with this ticker. It did not have such a ticker at all. To create the right outer join select statement, we need to replace the word left with the word right in the join command and change the prefix in front of the ticker column name. Now we need all data from the right table B and only rows that match Table B ticker values from the Table A. Look at the resulting table. The last row has the null value in the stock price column. This happened because the left Table A does not have stock price data for this ticker. This is a mirror-like situation to the previous example. Note that if we did not change the prefix in front of the ticker column name and retrieved tickers from the left column A in our right join statement, then we would get the awkward results where the last row either did not have the ticker value or the stock price value. In the same way as the inner join statement works the same without the optional keyword inner, the outer joins work the same without the word outer. These keywords are used to ease reading of the SQL code. Now let's see what happens if we execute the full outer join command on the tables A and B. The full outer join command includes all rows of the table A and all rows of the table B. Since we join tables on the ticker column, we will get the table with all the ticker values. The rows that did not match tickers from both tables will have null values in the cells. Here, the 4th row has the null-valued cell in the company name column. The 5th row has the null in the stock price column. The last join operation we will consider here is the cross join. For that, we will create another table called Group Numbers with one column, Numbers. We will populate this table with 3 integer values using the insert command. With the select statement, we check that the new table is properly populated with the values 1, 2, 3. To construct the cross-join select statement, we will use the select statement we created for the inner join. We will select ticker, company names, and stock prices from the inner join select statement and cross-join it with the group number table with the only column number. As with all join statements, we will create aliases to the table names and add it as prefixes to the column names. The resulting table has the data in 3 sets of repeating rows. The ticker, company name, and stock price values came from the inner join of Table A and Table B. Each row in this inner join is then repeated for each row in the group number table. This is how the cross-join operator works. As a result, we tripled the table we get from the inner join. Sometimes you will need double or triple data sets in your data science work. For that, you can use the cross-join operator, which is quite handy. Combining tables. Part 2. In the previous section, we considered join operations. Joins used with filters can create almost any combination of tables. However, the join statements easily can become too complex to read and expensive for the server to execute. To simplify the code structure and to improve SQL Server performance, sometimes we can use union, intersect, and except commands. In contrast to the join command, these commands work only with rows. In other words, all datasets in these commands should have the same columns. To illustrate these commands, we will depict tables as circles and place the circles one below the other. The commands union, intersect, and except can merge the tables with equal columns, return the common rows, or subtract one table data from another. In the example section, we will show how each of these operators works. We will start with creating 2 tables in our database S&P 500. Both tables will have 2 columns, company name and stock price. We will fill the tables using the insert command and add 3 rows into each. The only difference in the 2 tables will be the last row. The last row in Table A will have a different company record from the last row in Table B. We will use 3 rows for the illustration purposes only. For the commands we will show, the number of rows in the tables can be different. With the 2 select statements, we will check if the tables were filled with the data as expected. The 2 select queries are executed in one batch, so the result window shows 2 outcomes simultaneously. This is convenient when you want to compare 2 data sets. Now we will take these 2 select statements and combine them with the union statement. As a result, we will get a table where all distinct rows from Table A and Table B are united into one data set. If we want to combine all rows from Table A and B, ignoring possible data repetition, then we can use the union all command. Note that the resulting table has the repeating rows. The reason is that part of the data in Table A also exists in Table B. Remember that we intentionally constructed the tables with the repeating data. To list the data that is common in both tables, we can use the intersect command. The select queries with the intersect will only return rows that exist in both Table A and Table B. Lastly, if we want to find rows in the Table A which are unique for this table and do not exist in Table B, we can use the except command. As you can see, these three commands, union, intersect, and accept, are quite handy to use. Together with the join command, they form a powerful set of operators for combining tables. You will often meet these commands when you are working with views.